Okay, so let us try to see the solution to this. So if we look at this previous code of ours, the problem was that both of these lines 14 and 15, and similarly here 25 and 26, they did not execute atomically. There can be a context switch anytime when producer and consumer are executing these statements. Now one way of get rid of this problem is to use smart coding with the help of similar solutions that we have seen in the last lab. So two very celebrated solutions are Decker solution and Peterson solution, which are provided in the lab, but then using those kinds of solutions need really well mindset, as in it is not easy to come up with those solutions, requires a lot of thinking, and also those solutions might not work with the modern day operating systems, which also optimize some codes at their own end. So your codes are not always executing in the same order as you write the lines. Your systems might be doing some more optimizations at their own end. So let us now look at a better solution and an easier solution also, which is some functionality. So this is again from the handout for the previous class, which is on the WhatsApp group. So it is with the help of certain functionality which is provided by the hardware of the system, and although it looks like a code, why we are saying that it's the functionality provided by hardware, the idea is that few more instructions were available as a part of assembly language instructions. You see, normally your CPU can execute assembly language instructions like we discussed. Load count is one instruction which will execute in one go. So every assembly language instruction executes in one go. So therefore a few more assembly language instructions were added to the set of instructions that you could use, and here is an example. So try to take a look at this and see if you can understand what this code will do. So here is a simple function test and set, which is an instruction, an assembly language instruction provided to you. It will take a pointer as an argument, so you should be comfortable with pointers, as we have been emphasizing from the beginning of the course. And it does some kind of operations on these variables over here, and then it does something to the value which was passed to it, right, to the address which was passed to it, and it also returns something. So pause this video, take 5 minutes and try to think on your own what do you think this code is going to do, and you can put it in the comment box if you try on your own. Okay, so if you are back, you would have realized is what this instruction does is it takes the current value of lock, and that is what is returned, right? So it is simply as Ram takes a look, he sees whether lock is there or not, and that is what is returned, irrespective of whatever was the old value of lock. The new value is locked, that the lock is applied, that's all. Right, so it returns the old value of lock, and no matter whether it was locked or not, it locks it. So that is what is happening. But the beauty of this function, or the beauty of this instruction, is when you execute it on your computer, it will happen in a single shot, like an atomic instruction. And you have to be careful. What you should not do is to copy paste this code in the current code and try to run it. If you are doing that, that means you are defining a function of your own. You don't have to define a function of your own like this. Here we are only showing you how this instruction works. If you actually want to use this instruction, you should use this direct function which is called test and set, and I don't think you need to add a library for that. It's just like you have a printf and scanf function. So you can use this function in your code and pass it the address of lock, right? What this function will do, the value that this function returns is whatever was the old value of lock, and it sets the lock. So again, for understanding this, you should try to understand this function, and now you can use this instruction in your code in place of both of these lines, and you can get, with the help of that test and set instruction, you can get both of these lines done in a single shot, and that is our solution. So again, you should think a bit about it, what is happening here, right? Try thinking about what if the current value of lock is 1. If lock is currently 1, it is going to return a 1, and the lock is also going to remain a 1 after the instruction executes. If lock is 0, it is going to return a 0, but after the instruction executes, lock is going to be changed to 1. Right, that is what this does, and let us now try to use this instruction here. Again, you should do this thinking on your own. I am telling you the solution here. All you have to simply do is use this test and set instruction here and pass it the address of lock, and now both of these instructions will happen in a single go. Right. I hope that it doesn't require any additional libraries to be included. Let us see. I think let us just check if this resolves our problem, and we'll do a similar thing over here. For both of these lines also we simply need to do, and you should remember that, you should think that why we have this test and set sitting in a while loop, right? Because you have to test it again and again. So till the time your test and set it returns a 1, that is lock is applied, you again keep on moving in the spin lock. The moment lock is removed by either consumer or producer, it returns the old value of lock, which was 0. So it passes through this particular, it comes out of this loop and sets the lock. But that happens as a single atomic unit. So that is the hardware solution that we are using here. I really hope it works. So I get an error. It says undefined reference to test and set. I probably need to include a library here. Let me see if it is mentioned in a document. If not, it is given here. So this instruction is not simply called test and set. Here is the instruction how it really looks like in C. You see, slightly it looks complicated, but what it does is exactly the same thing as test and set. So it is called sync lock test and set, and you pass it the old value of lock, right? So let me try to bring this in our code. Instead of this, let me use this. So this is double underscore sync lock and test, and instead of this you see pointer, right? This just tells you the syntax of the function, that is you should be passing an address here, and that address is nothing but the address of lock. I am not really sure what this value is, so the best way to do it is, I have my friend ChatGPT open here, and let me ask it, what do the two arguments denote? Let us see what it says. What happened? Okay, let's say it says it's a built-in function used for implementing synchronization mechanisms. Type is the data. Value is the value that will be set in the variable pointed by PTR, right? Basically, what do you want to do to the final value of lock, right? Final value of lock, no matter lock was there or was not there, the final value we want it to be 1. That means the moment, every time you implement this particular function, if lock was there, you keep it applied. You cannot remove it on your own. Consumer will remove it if consumer is running in its critical section. And similarly, if lock is there, you actually set the lock, because you have to go inside. And so let's take the same thing over here and place it here, and let us now try to see if we have resolve the race condition now. Fingers crossed. It is resolved. You see, now you run your code a million times, 10 million times. you have synchronization. So both consumer and producer, they are not entering their critical sections at the same time. So here is just one instruction that we have taken a look at that allows us to provide this synchronization, which is called test and set instructions. There are many like that. One more which is a part of your syllabus is compare and swap. You see, that is again a similar instruction, right, which will have multiple instructions, but then the assembly language or your CPU will ensure that they are executed in one go. So your homework, take a look at compare and swap instruction, how it looks like, see how can you use it in a C code and try to achieve the same synchronization with the help of your compare and swap instruction, right. And you can always use ChatGPT for this. Our objective here is to learn and achieve the tasks, right. So though you can use ChatGPT, you should have an understanding of what is happening. So this is one way of doing it, and we what we have done here is at a very basic level, right. We have directly used an assembly language instruction or your C instruction, a low level instruction provided here. In the next video, we will make this process all the more easy. And again, thanks to Dijkstra, he actually created a data type for this, and right, so you would have heard the term abstract data types, and now, so the point is everything inside an abstract data type, right, that is hidden, and you can just directly use it like a magic. Although we will also take a look at what is that abstract data type, how it looks, and how you can use that in your code. Again, something more simpler than using a statement like test and set and compare and swap comes up in the next video.